Section 6.5b is about absolute value inequalities. So we're going to replace the equal sign with inequality symbols and see how that changes things. I want to consider absolute value less than a number. So I'm going to pick the example absolute value of less than 5. Well, what does that mean? That means the distance from 0 is smaller than 5 units. So let's graph that and see what we're looking at. 0 is our middle number, like we learned about last time, and the distance here is going to be 5. But it's not going to be equal to 5. It's going to be less than 5 units. So if I were to graph that, I'm not going to include the 5 and the negative 5 because those equal 5 units away. I want all the numbers that are a smaller distance, which means I want all these numbers that are in here. These are all the numbers that are smaller than 5 units away from 0. Now what kind of a graph does that look like? If you said and, you're correct. That's an and graph. It turns out that absolute value equations that are less than are always going to be ands, always. And when you set them up, to solve them using algebra, here's how you set them up. You always say they're greater than the negative version of the number, and they're less than the positive version of the number. That's important. Whenever you have a less than absolute value, you drop the absolute value sign and you say greater than the negative and less than the positive. You always set them up that way. Now let's go over here and consider the greater than possibility. Absolute value of x is greater than 5. Again, we'll graph. The middle value we've said is 0. We're going to be 5 units away on either side, but now we want the distance that's greater than 5 units. Well, if I want the numbers that are bigger than 5 units away, I'm talking about all of these numbers. And I want the numbers that are greater than 5 units away from here, that's all these numbers. Well, what kind of graph does that look like? If you said an OR, you're correct. That's typically what an OR graph looks like, as we've learned in the past. So setting up an absolute value inequality with greater than looks like this. You drop the absolute value sign and you say less than the negative or greater than the positive. That is how you always set up less than and greater than problems as absolute values. You always set them up this way depending on if it's an and or an or. Here we have to solve an absolute value inequality. If you remember from the last slide, a less than problem means this is going to be an and. You only remember that by remembering it. Less than is and. That's it. So what do? You take the t plus 5 and you compare it to the negative 9. And you take the t plus 5 and you compare it to the positive 9. Now what symbols do we use? Go back here. If it's a less than, you're going to go greater than the negative and less than the positive. So we'll do that. We'll go greater than negative 9, less than positive 9. Once you rewrite it this way, it's just a typical and problem that we've done in the past. Subtract 5 from both sides, so t is greater than negative 14. Subtract 5 from both sides, t is less than 4. It's an and problem. So we want the numbers that are greater than negative 14 and less than 4. If you need to write 3 graphs to solve this, please go ahead and do that. But some of you might be able to do this without that. These are bigger than negative 14, and at the same time, they're less than 4. One more thing I want to do is I want to combine this into a single answer. So negative 14 is on the left, which is less than t, which is less than 4. Here's another absolute value inequality with a less than, so you know it's going to be and. So c minus 2, we compare it to the negative 6. And c minus 2, we compare it to the positive 6. Remember that an and is greater than the negative and less than the positive. So that's how you set them up. Now we'll solve. C is greater than negative 4. C is less than 8. So we'll graph. We want all the numbers that are bigger than negative 4 and smaller than 8. Open circles because there's no equal to. Shade in between. We'll say negative 4 is less than c is less than 8. Here's an absolute value. Notice this one is a greater than, which means it'll be an or problem. So we'll drop the absolute value, compare it to -6, and we will compare to +6. The question is, what are the symbols? We'll go back to the first slide we did. In an or problem, you always go less than the negative, greater than the positive. So that's how we're going to set up all of our or problems. Less than or equal to the negative. Notice I had to put equal to because this is equal to, and greater than or equal to the positive. So that's how you set them up. Now we'll solve 2x less than or equal to -14 dividing by 2, x less than or equal to -7. Same thing over here. So 2x greater than or equal to -2 dividing by 2, x greater than or equal to -1. So there's my solution. Again, if you need to do two graphs, feel free to do that. Here's -1, here's -7. I'm going to go less than or equal to -7. And then also I'm going to go greater than or equal to -1. Remember, it's an or problem, so we want the union. They don't have to overlap. So here's my solution and my graph. Here's another or problem because it's greater than or equal to. So 2g plus 5. In an or, we go less than the negative. Make sure we do equal to because this one's equal to. And then 2g plus 5 is greater than the +7. So g is less than or equal to -6. G is greater than or equal to 1. It's an or problem. So less than or equal to looks like this. All those numbers are less than or equal to 6. All of these numbers are greater than or equal to. Here's a concept summary of everything that we just went over. It's a good place to find all this information in one place. If you have an absolute value that's equal to a number, you set it equal to the negative, also the positive. If you have an absolute value that's less than a number, then you set it greater than the negative and less than the positive. Now, I don't like the way that they write this. I would prefer to do it this way, greater than the negative and less than the positive, just because I like to keep positive numbers on the right and negative on the left. Sorry, should have been an n because we could talk about any number here. And then absolute value is greater than n. That's going to be less than the negative or greater than the positive. One more thing I want to say about absolute values, and it involves negatives. I want you to think about these two, but I want you to think about them compared to -3. What if I say that there's an absolute value that's greater than a negative and an absolute value that's less than a negative? Well, remember that absolute value means distance. How many distances are bigger than a negative number? And the answer is all of them. If you ever have an absolute value that's greater than a negative, you know immediately that it has to be all real numbers. Any number in the world works in here because they all have to be greater than negatives. Likewise, if you have an absolute value that's smaller than a negative, that will never happen because you can't have any distance smaller than a negative number. It's impossible. You can't have a negative distance. So be on the lookout for negative numbers over here. You don't have to do any work. Just think about, can I be greater than the negative for a distance or less than the negative for a distance?